Spatial joins are very different than table joins. With spatial joins, we're matching records based on a spatial relationship instead of a key in the attribute table. And by spatial relationships, we mean things like intersection, proximity, and containment. And then for things, for example, proximity, it can be within a distance of, it can be the closest thing to, it can be all these different things that we can choose from. But just like with table joins, we're going to have a target feature class now instead of a target table, and we're going to have a join feature class. And what we're basically going to make is a new layer or a new output feature class that's going to have cities, once again, but a new set of cities, and then it's going to have all of the attributes from both the target feature class and the join feature class. So let's look at some examples. This one uses the command intersect, right? So if we look at these different ones here, intersect is one of the intersection type of ways that we can join records. And we're using intersect here, and we're combining parcels with zoning. And because these two overlay each other very well, the zoning is actually based on combining parcels in some way, then we get records that look like this. So we're still getting a new output layer that looks like the parcel layer because that's where the polygons are coming from, but then it has additional information with it from the table for the zoning. Here's another example here based on proximity. So if we flip back to slides, proximity would be these ones here. For the proximity, we're looking for a spatial join where we're looking at the names of various cities and then the names of airports and which cities would be closest to these airports. So in the output here, we have once again the list of the cities, and then this was joined not by a common row or common column in the attribute table, but by ones were within a certain proximity, cities that were within a certain proximity of these airports. And so the information from the airport table is added to this table here. The layers would still be where the airports are, but now those airports would have all of this different information associated with it, or the cities would have all this different information associated with it about what was the closest airport and how far away that airport was coming from this airport feature class here. Here's another example here. We could look at a geologic map where each one of these colors represents a different geologic unit. And then we could look at where septic systems are here. And so we have all these septic systems shown in green here. And this one uses containment. So if the septic system is within a certain geologic unit, then that geologic unit is added on to that unique identifier for that particular septic system. So for example, here's 800, and we would see that's associated with the terrace deposits or QT, and we can see that's exactly what's occurring here. Now, in some cases, slightly different commands like the intersect and within can give different results. If we do the intersect or within command to the data that we see here, we would actually get the same output. But what if one of these points fell directly on one of these lines here? So the within operator would say, well, that point is no longer within one of these polygons because it's right on the boundary of two of these polygons. So it would not select it, and we would get a null output if we use the within operator. However, if we use the intersect operator, it can occur on the boundary or inside of the polygon. So in that case, it would be selected for both. We would actually have two matches for this for one of these points if it fell directly on one of these boundary lines.